I want to take a look at move forward. Move forward. If I go down more specifically, here's the actual move forward function. I want to take a look at is blocked, because this is the function that decides whether the player is actually moving forward or not. And the important part is blocking OBJs. So we're checking if anything is in the dictionary, blocking OBJs. If the dictionary is empty, we can move forward. If not, the character is blocked, cannot move forward. So this is the function, check blocking OBJs. I want to clean this up a little bit because I want to be able to use the same function to move up, down, whichever direction I want. And this is the part. This part, I want to be able to reuse this. And in order to reuse it, I'm going to create a function. I'll call it check raycast collision. And I want to copy this entire part under for each loop. Put it in there. And I want to check the variables. So we want the game object, which is O, OBJ. Replace all the O's. Okay, so O is the starting point of the raycast. We also want the direction of the raycast, which is this part, forward multiplied by direction of the block distance. I'll just call it vector3 dir, as in direction. And replace this part. That's the direction. I also want the length of the distance, blocking distance, block distance. So wherever we have the direction and the distance, we replace it. Direction multiplied by block distance, dir. No, this is just the direction. Distance goes here. Block distance. We also need the dictionary, blocking OBJs. So put that in there. Dictionary of the game object as a key and the game object as the data. Blocking OBJ dictionary. I'll make it a little shorter. So we'll replace that. Blocking OBJ dictionary. And I think that's it. So now I'm going to go back up and get rid of this entire part and replace it with the function check raycast collision. Pass on all the variables. O is the game object. Direction. Okay, I'll make this 1 and -1. We get the forward direction multiplied by the direction of the block. So we're either going forward or backwards. And the block distance, we get it from the move forward ability. Block distance. And we get the blocking OBJ's dictionary. So everything should be exactly the same, except we've added what was on the for each loop, we've added into a single function. And if I play, the draw debug line. This is the actual checking collision part. Okay, let me play again. Okay, so now we get the actual distance of the block distance, even when we draw the debug line. But this part is a little weird. Seems like the direction is off when I'm walking to the left side. So right side seems fine, but the left, we have the raycast going in the wrong direction. I think it's this thing that's causing the problem. We've hard-coded the forward direction. Instead of the world direction forward, we want to get the relative direction of this game object. So this transforms forward. Save, and I'm going to go back and play. Okay, looks like it's working fine. So if I'm going to the left side is the forward. If I'm going to the right side is now the forward. And the gameplay is exactly the same.